Adrian Newey joined Aston Martin to build a championship car. Instead, the first day of the 2026 season ended with a nightmare. Fernando Alonso did not run in the first practice session. Lance Stroll completed only a few laps. And when the cars finally managed to stay on track, Aston Martin were more than 5 seconds slower than the leaders. 5 seconds. In modern Formula 1, that is not a bad start. That is a disaster. But the lap time is not the real problem. Because inside the Aston Martin garage something even more alarming was revealed. The team arrived in Australia with only 2 battery units for the entire weekend. 2. And if one fails, there may be no replacement. Now combine that with another detail most fans have not noticed yet. Severe vibrations coming from the new Honda power unit are shaking the entire car. So much that Fernando Alonso admitted parts of his hands were going numb during runs. And that raises a terrifying possibility. A team built to fight for championships might struggle just to finish the race. Today we are going to break down exactly what happened on the first day of the Australian Grand Prix. Why the AMR26 is already facing serious technical problems. What Adrian Newey has reportedly said behind the scenes. And the hidden issue with the Honda engine that could define Aston Martin's entire season. But before we go deeper into this story, make sure you subscribe to the channel. Because what we discovered about this project gets even more serious. The story of Aston Martin in Australia did not begin on Friday. It actually began months earlier. Because the AMR26 was never supposed to arrive in Melbourne like this. For almost 2 years, this project had been sold as the future powerhouse of Formula 1. Lawrence Stroll built a completely new factory in Silverstone. Hundreds of millions invested. New wind tunnel. New simulator. New engineering departments. Everything designed for one specific moment. The regulation reset of 2026. And then came the move that shocked the entire paddock. Adrian Newey, the most successful designer in modern Formula 1. The man behind championship cars at Williams, McLaren, and Red Bull. When Aston Martin convinced him to leave Red Bull, many people inside the sport believed something historic was about to begin. Because Newey had the opportunity every engineer dreams of. A completely clean sheet of paper. New aerodynamic rules. New engine regulations. New energy systems. No legacy limitations. No old design constraints. Just pure engineering freedom. And that freedom produced the AMR26. A car built around one extremely aggressive concept. Maximum aerodynamic efficiency. Extreme packaging. Every component pushed to the absolute limit of space and airflow. But here is where things start to get complicated. Because the car was not designed alone. It was designed together with Honda. The Japanese manufacturer returned as a full works partner. Meaning the engine and the chassis had to be developed together from the very beginning. In theory, that is the ideal situation. Perfect integration. Perfect packaging. Perfect balance between power unit and aerodynamics. But in reality, that kind of integration can also become extremely dangerous. Because if one part of the project falls behind, the entire car suffers. And according to several reports coming from inside the paddock, that is exactly what happened. Honda arrived with a brand new power unit concept. More electrical power. More energy recovery. A system designed specifically for the new regulations. But during early dyno testing, engineers began to notice something unusual. The engine was producing higher vibration levels than expected. At first the numbers did not look catastrophic. But when the power unit was installed into the extremely tight packaging of the AMR26, the situation changed. Because Newey had designed one of the most compact engine installations on the grid. Minimal space. Minimal margins. Everything optimized for aerodynamic performance. Which means any vibration inside that structure travels directly through the chassis, into the battery, into the electrical components, and eventually, into the cockpit. This is where the real danger begins. Because the battery pack in these new power units is not just another component. It is one of the most sensitive and critical parts of the entire system. Under the 2026 regulations, electrical deployment plays a massive role in lap time. Cars must recover huge amounts of energy under braking, store it in the battery, and deploy it again on the straights. Without that system working perfectly, the car loses enormous performance. But the battery also operates under extreme conditions. High temperatures, massive electrical loads, and now, constant mechanical vibration. And if those vibrations are strong enough, they can damage internal components of the battery pack. That is exactly the fear inside Aston Martin. Because during winter testing, the engineers started seeing signs that the battery system was under serious stress. Runs had to be shortened. The car had to return to the garage repeatedly. Inspections became more frequent. And every time the team opened the car, they were looking at the same combination of issues: vibration, electrical instability, and thermal stress on the battery system. At that moment the team realized something uncomfortable. The car might be aerodynamically brilliant, but if the power unit cannot operate safely, none of that performance matters. And Adrian Newey himself reportedly warned months ago that the project might not be ready for the start of the season. Not because the design lacked potential, but because the integration between the Honda power unit and the extremely aggressive Aston Martin chassis had become one of the most complex engineering puzzles on the grid. And that puzzle followed the team all the way to Melbourne, where the first day of the 2026 season finally revealed the full scale of the problem. Because what happened during free practice 1 was not just a technical setback. It was the first public sign that this project might be far more fragile than anyone expected. And what happened next inside the Aston Martin garage made the situation even more tense. Friday morning in Melbourne was supposed to be the moment Aston Martin finally understood their car. Instead, it became the moment the entire paddock realized something was seriously wrong. Because when free practice 1 began, one Aston Martin never even left the garage. Fernando Alonso's car stayed inside. No installation lap. No slow run. Nothing. Just engineers surrounding the car, checking systems, studying data, and speaking quietly over the radios. Officially the team described it as a potential power unit issue. But inside the paddock, people immediately connected the dots. The same vibrations. The same electrical concerns. The same battery stress that had already caused problems during winter testing. And remember something important. Aston Martin arrived in Melbourne with almost no margin for error. Only 2 battery packs available for the entire weekend. The same 2 already installed in the cars. Which means running the car aggressively during practice carries a huge risk. If vibrations damage the battery, if the electrical system overheats, if the internal components suffer even small structural damage, that battery cannot simply be swapped for another one. There may not be another one. So the team made the safest decision possible. Do not run the car. Protect the hardware. Protect the only battery available. But that decision created a different problem. Because the AMR26 desperately needs track data. This car is new. The engine concept is new. The electrical system is new. Every lap is valuable. Every sensor reading matters. Without laps, engineers cannot understand the behavior of the car. They cannot study the vibrations. They cannot evaluate the battery temperatures. They cannot test energy recovery levels. And most importantly, they cannot improve the setup. So while other teams were learning their cars during the first session of the year, Aston Martin were watching from the garage. But the situation became even more worrying once Lance Stroll finally went out on track. Because at first it looked like the team had solved the immediate issue. The car left the garage. It completed an installation lap. Everything seemed normal. Then Stroll started a proper run. And only a few laps later, the car was called back to the garage. 3 laps. That was all. 3 laps of useful running. Then the engineers shut everything down again. Which means the entire first practice session produced almost zero data for the team. One driver who never ran. One driver who ran only a few laps. And a car that still showed the same symptoms seen during testing. At that moment, something very unusual started happening in the paddock. Teams began looking very carefully at the Aston Martin garage. Because when a team limits running that aggressively on the first day of a season, it usually means the problem is serious. And the mechanics inside the garage were not moving like a team performing routine adjustments. They were moving carefully, methodically, almost cautiously. The kind of behavior you see when engineers are protecting fragile hardware. And that is exactly the fear surrounding the Honda power unit. Because the new engine is not just suffering from vibration. It may also be struggling with one of the most important performance targets under the new regulations: energy recovery. Under the 2026 rules, the electrical side of the power unit produces a massive portion of the total power output. Cars must recover huge amounts of energy during braking, up to hundreds of kilowatts. That energy is stored in the battery and redeployed through the electric motor. Without that system working perfectly, the car becomes dramatically slower on the straights. And according to several technical reports, the Honda unit may not yet be reaching the expected recovery levels, which creates an even bigger problem. If the system cannot recover enough energy, the battery cannot deliver maximum electrical power during the lap. That means less acceleration, lower top speed, and huge lap time losses. Suddenly the 5-second gap we saw in practice begins to make more sense. Because if Aston Martin are forced to run the engine in conservative modes to protect the battery, then the car is not running anywhere near its real potential. But the most revealing moment of the day came later. Free practice 2. The session where Aston Martin finally allowed both cars to run longer stints. And for the first time that day, the battery survived the entire session. No failures. No shutdowns. That sounds like progress. But then the timing screens told a completely different story. Because while other teams improved their lap times, Aston Martin remained far behind. Roughly 5 seconds slower than the fastest car on the grid. 5 seconds. That is not just lack of pace. That is operating in a completely different performance window. And when engineers started analyzing the data after the session, one uncomfortable realization became impossible to ignore. This was not just a bad setup. Not just a difficult circuit. Not just first race struggles. This looked like a deeper structural problem. A problem that might take months to solve. Which leads to the question everyone in the paddock is quietly asking tonight. If the car is already this fragile, if the battery system is already under this much stress, and if the engine cannot yet deliver the electrical power required by the regulations, then what exactly happens when this car tries to run a full Grand Prix distance? 58 laps. Maximum load. Maximum electrical deployment. Maximum vibration. Because if Friday already looked this difficult, the rest of the weekend might reveal an even bigger problem.